Okay, these are the notes for the algebra, unit 3. We're going to talk about independent and dependent variables. Independent variables is the variable that represents the input values of a function. Values of a function. Okay. Well, if that's input, which if you remember from our previous notes, that input was the x values, the set of all possible, and we don't always use x and y, but when I show you an equation, I'll show you how it's really easy to tell which one's input, which one's output. And so the dependent variable is the variable that represents the output values of a function. Okay, and a thing to remember is that for dependent variables, it's dependent. It is dependent, so just to remember, dependent on the independent variable. And I'm just abbreviating that, independent there, okay? So the independent variable is something you plug in. And based on that is what your dependent variable ends up being. Okay, and so then we're going to go to the independent, dependent variables. Let's see, that is... Okay, so we're going to look at number 17 here. Okay, so go to your number 17 in your notes packet. Okay, so here it gives you a function, y equals negative 3x plus 12, and y is the amount of fluid ounces of juice remaining in a bottle after you take x number of drinks. And it wants you to identify the independent and dependent variables. Well, if you look at an equation, we're going to plug in values for x and do this math to it, and that gets us our value for y. That y equals kind of gives away the fact that the y is dependent on whatever x is, okay? I'm going to plug in things for x and get my y. But if you read what it's talking about fluid ounces of juice remaining in a bottle after you take drinks. Well, you taking a drink is what's affecting the juice remaining in the bottle. So the taking drinks would be independent. How much juice is left would be dependent on those number of drinks. So the dependent variable is x, which equals the number of drinks. Okay? The dependent variable would be y, and that is the amount of fluid left. Okay? And so this wants us to say, okay, so if my domain is 0, 1, 2, 3, and 4, I want to find the ranges. So I'm just going to plug in those numbers here for my input. And then anywhere in the equation I have that x value, I'm going to put that. So it's negative 3 times 0 plus 12. So that gives me 12 for my output. The input is 1. I get negative 3 times 1 plus 12. My output would be 9. Then I have negative 3 times 2 plus 12. That gives me an output of 6. Input of 3, so I have a negative 3 times 3 plus 12. Gives me output of 3. And the negative 3 times 4 plus 12 is going to give me an output of 0. Okay? So I'm putting in x's that gives me the y's. Okay? So that's how you can tell the independent and dependent when I give you an equation. So if you look at, flip it over to 18. So now it gives you a function of, a equals a negative b plus 14, represents a is the the number of avocados you have left after making B batches of guacamole. So it doesn't matter, my number of avocados is not going to affect the batches of guacamole in this equation, even though if you don't have avocados, you don't have guacamole, but that's not what it's saying here. You will have all these avocados, and those avocados don't determine the batches of guacamole. You actually making the batches will determine how many avocados you have left. So the independent would be your batches of guacamole. And again, I'm going to just say guac there. And the dependent would be the number of avocados left. Whoops, if I can spell. There we go. Okay, so now it's going to tell me, okay, my domain is 0, 1, 2, and 3. What is the range? So I'm going to make, if I don't make any batches, how many avocados do I have? If I make 1 batch, 2 batch, or 3 batches, then how many avocados do I have? So I'm going to plug them in. So if I plug in 0 here, I'll just make a t-chart for this. I'm going to plug in 0, 1, 2, and 3. Okay. If I plug in 0, that means I have a negative b. No, I don't. I have a negative 4 times b, and I'm saying b is 0 plus 14. So that means I have 14 avocados to start with. If I make 1 batch of guacamole, I'd have a negative 4 times 1 plus 14, and that'll give me 10 avocados left. If I make 2 batches of guacamole, I have a negative 4 times 2, that's negative 8, plus 14 is going to give me 6 avocados left. Make 3 batches, negative 4 times 3 plus 14, and that will give me 2 avocados left. And if you tell that negative 4 means I used 4 avocados for every batch of guacamole. So now I only have 2 left, so I can't even make more batches of guacamole. I don't have enough avocados. I can make half a batch. But this wanted my actual range, which is the Y values. Now, a range, we write in numerical order. And this is a set of numbers. We write it in numerical order from least to greatest. So I actually have to say my range is 2, 6, 10, and 14, and close your set. Okay? Now, number 19 here, it gives me a function, t equals 19m plus 65, and it represents the temperature, T stands for temperature, in degrees Fahrenheit of an oven after preheating for m minutes. Okay, so the minutes are what's going to affect the temperature. Okay, so the longer I have it heated, the higher the temperature will be. So minutes will be independent, and you can tell it because it's over here on the side of my equation where all this stuff is happening, all the math. Okay, and that means the temperature is my dependent. Okay, and now this calls for a recipe. The recipe calls for the oven to be 350 degrees Fahrenheit. We want to describe the domain range of the function. Okay, so I want to even just find my domain and range. So let's do that. So I know the highest temp is going to get 350. So I could do a chart. Okay, at 0 minutes, I know the temperature of the oven is going to be 65 because 19 times 0 plus 65 is going to be 65. And I don't want to plug in all of these. Okay, I don't want to plug in tons of inputs here. But I do know my final output is going to be 350 because this is the degrees Fahrenheit, right? And then this is the minutes over here. So I want to figure out how long it's going to take for the oven to get to 350 degrees. So I'm going to take this equation. I know the temp at 350. I want to know the minutes. So I'm going to say 350 equals 19m plus 65. And now I have a 2-step equation I can solve. I'm going to subtract 65 from both sides, and then I'm going to divide by 19, and then I'm going to tell you you get 15. Okay, 15 minutes. So in my t-chart, I can plug that 15 in over there. So my domain is a bracket. It could be at 0 minutes, but it goes all the way up to 15 to get to that 350 degrees. And then range, started at 65 and goes all the way up to 350. Okay? So if it describes the domain range, well, the domain, it takes 15 minutes for the oven to heat up from 65 degrees to 350 degrees. So that's all that the domain and range mean in this problem.